In this question, we want to find an equation of the tangent line to the curve at the given point. Equation of the tangent line. Okay, equation of tangent line that is given by y equals mx plus b, or we also know the formula y minus y1 equals m x minus x1. In any case, we need to find the slope m, slope of the tangent line at the given point 1, 2. So we want to find the slope of tangent line to this curve at this point 1, 2. Okay, and we know by equation, by formula 1, the slope is given by the formula limit of fx minus fa divided by x minus a as x tends to a, provided this limit exists. Okay, let's do it. Limit x tends to a is the given point in this question. This is a and this is corresponding y coordinate fa, fa. Okay, a is 1, x minus a is 1. Fx is the given curve. Given curve is square root of x plus 3 minus fa, that's the corresponding y coordinate for a, that's 2. Or if you plug in a equals 1 in this curve, you get that corresponding y. Now this is a question that we've seen in section 2.3. all we have to do is find this limit when x goes to 1. If we simply plug in x equals 1, 1 plus 3 4, square root of 4 is 2 minus 2, we're going to get 0 over 0. Okay, so we need to simplify this fraction before we plug in x equals 1. Now how can we simplify? The general method would be just factor the top, factor the bottom, cross out the zero making factor, but that's not the case. We have a square root. So whenever we have a square root, we multiply by the conjugate, in this case conjugate of the top. So that's square root of x plus 3 plus 2, that's minus 2 is different, and same thing on the bottom, square root of x plus 3 plus 2. We are multiplying this fraction by 1. Same thing on the top and bottom, means we are multiplying by 1, and that's legal. Now we want to multiply the tops and multiply the bottoms. We multiplied by the conjugate because of the top. Okay, so the issue here is on the top, so we don't do anything on the bottom. We just copy both factors. Now x minus 1 times this whole thing, x plus 3 plus 2. On the top, we just distribute. It's kind of FOIL. Okay, first term to first term, first to second, then second to first, and second to second. So square root of x plus 3 times square root of x plus 3. It's like if we multiply square root of x times square root of x, then we get square root of x quantity square root cancel, just x. So in the same way, square root of x plus 3 times square root of x plus 3, simply x plus 3. Okay, then first to last, so 2 times this square root, a plus sign, so plus 2 times square root of x plus 3. Second to first, so minus 2 square root of x plus 3, and finally negative 2 times positive 2, that's negative 2 times 2, 4. Okay, and since we are trying to simplify the top, if you look at the middle two terms, these two cancel, and 3 minus 4, that's negative 1. Okay, so we have now limit x tends to 1. On the bottom we have x minus 1 square root of x plus 3 plus 2, outside, and x 3 minus 4 is negative 1, x minus 1. We can put parentheses around, then we can cancel x minus 1, x minus 1. Okay, and we plug in x equals 1, so we get 1 over, so x equals 1 plus 3 4, square root of 4 is 2, 2 plus 2 4, so 1/4. So we just found the slope of tangent line to the curve at the given point. That's 1/4. That's the slope m. Okay, that's m. Now we want to use the equation of tangent line, any of these two formulas, and find the equation. So let me erase this one. Okay, now I want to use the second one. You can go for the first one. Y minus y1 equals slope x minus x1, where x1 y1 is the given point, in fact a of a 1 2. Okay, this is 1 and y1 is 2, and slope we just found 1/4. So y minus y1 is 2, slope is 1/4, x minus x1, x1 is 1, because 1 2 is the given point here. Let's simplify. Y minus 2 equals, distribute 1/4, so 1/4 x minus 1/4 times 1/4, move 2 over, so pretty much add 2, so y equals 1/4 x, negative quarter plus 2, 2 minus quarter, 2 minus quarter is 1 and 3/4, right? 2, that means 1 and 4/4, 4/4 minus 1/4 is 3/4. So that's the final.